So for this next section, we're going to look at converting to mod arg form. So yeah, so pretty much if you follow these steps, it should be pretty easy. So always draw a diagram first, just to make sure you have your array or your vector in the correct quadrant. Then we're going to find the modulus using what we learnt last lesson, and then we're just going to use SOHCAHTOA to find the angle. So most of the time, it will pretty much be always tan that we use though. All right, so the first one, 1 plus I. So remember, as a coordinate, this would be, the x value would be 1, the y value would be 1. So it would be here. So know the distance there is 1 across and then 1 up. And then that'll be the angle we need to find. So first thing, let's just find the modulus. All right, next we need to find the argument. So in this case, theta is just the argument. So argz would be, and then we know that just makes a right angled triangle. And then that uses inverse tan of opposite over adjacent, which is 1 over 1. And that gives us 45 degrees, or pi and 4. So now we have the modulus and the argument. That means this in mod arg form is just going to be root 2 cis pi and 4. Or you can write it the long way, root 2 cos pi and 4 plus I sine pi and 4. All right, so the next one, same thing. We're just going to draw our point. So it's -1 across, and then root 3 up. And that's the angle there. All right, so let's find the modulus first. So the modulus, same as usual, square root of the real bit squared plus the imaginary bit squared. Don't include the I. And then that'll just give us root 4, which is 2. All right, so now we have to be careful here, because when we find theta, we'll find theta first. So with this one, remember that the argument is angle between the x-axis, positive x-axis, and the ray. So in this case, this is the angle we want. But yeah, let's just find theta first. So same as before, theta is just going to be inverse tan of root 3 on 1. And then that would give us 60 degrees. So in radians, that's pi on 3. So that means this red angle here is just 180 minus 60, or pi minus pi on 3. So that gives us 2 pi on 3. So that means this in mod arg form would be, so the modulus 2 cis and then 2 pi on 3. So yeah, this next one, I'll give you guys a few minutes. So yeah, just pause this video, have we got this next one, and then unpause the video and the answer should appear. All right, so hopefully you guys would have got 4 root 2 for your modulus, or you got -3 pi and 4 for your argument. So remember, if you found theta, that would have been pi and 4, but because we want the principal argument, it's the angle between the x-axis and the ray, the positive x-axis. Remember, the principal argument has to be between -pi and pi. All right, so one quick question to finish up. So just say if we have to go back to standard form, this one's pretty easy. So pretty much let's just rewrite this, but we'll write the long version. So root 3 cis 5 pi and 6 is the same as root 3 cos 5 pi and 6 plus I sine 5 pi and 6. And pretty much we just simplify it. So root 3 and then cos 5 pi and 6. So you can calculate that to be, it'll be root 3 on 2. And then sine 5 pi and 6, that's just a half. So it'll be a half I. And then we'll just expand the bracket. And we've just converted back into standard form. So yeah, a lot easier than converting to mod arg form. A more formal way of thinking about it is that cos 5 pi and 6 is the same as cos pi minus pi and 6, which is the same as negative cos pi and 6, since it's in the second quadrant. Similarly, since sine pi minus pi and 6 is in the second quadrant as well, we know that sine's positive there. So you'll just stay as positive sine pi and 6. All right, so next time we'll look at proving identities.